Today we're trying to solve this problem called maximum and minimum sums of most size k subsequences. So in this problem we are given an array nums and a positive integer k, and we need to return the sum of maximum and minimum elements of our subsequences of nums with at most k elements. And then since the answer may be very large, we turn it in modulo of 10 to the power of 9 plus 7. So let's look at the first example. In the first example, you're given integer array 1, 2, 3, and with k equals to 2, and you should return the answer 24. So the explanation for that is the subsequence of nums with at most 2 elements are, so this is the first subsequence, the minimum is 1 and the maximum is also 1, and 1 plus 1 is 2, and the second subsequence is 2 and the minimum is 2 and the maximum is also 2, and 2 plus 2 is 4, and another subsequence is 3. The minimum is 3 and the maximum is also 3. 3 plus 3 is 6, and another subsequence is 1, 2, and the minimum of this subsequence is 1, because 1 is less than 2, and the maximum is 2 coming from here, so 1 plus 2 is 3, and another one is 1, 3, and the minimum is 1, and the maximum is 3, so 1 plus 3 is 4, and the final one is 2, 3. The minimum here obviously is 2 and the maximum here is 3, so 2 plus 3 is 5. So you can add all of these up and the total will be 24. So you may notice that 1, 2, 3 is also a subsequence, but it does not appear here because we have a limit of k equals to 2. So that's why the subsequence 1, 2, 3 with the minimum as 1 and the maximum as 3, it doesn't appear in one of the answer. That's why, because we have this k equals to 2 limit. So if this is k equals to 3, this particular subsequence will also be considered. So just for the example, this will be like what, 4, like. So 4 will be added to the answer, so the total should be 28. So yeah, that's a little bit of out of the topic. So anyway, so that's why that particular sequence is not considered as one of the answers. So we just consider all the subsequences that are less than or equal to size of 2. These are already subsequence. So we'll just return 24 in this case. So that's enough for the example. Let's think about the intuition. In this kind of problem, usually you just want to, you just want to sort the answer and also try to make the input size a little bit larger. So, for example, we'll have like something like 1, 2, 3, 4, 5, 6, and then maybe 10 or maybe 12, maybe 15. So as you can see here, like after the nums is sorted, it will look something like this. Okay, so just take a look at the arbitrary index. So let's take a look at 5. So what sequence can it do? So let's assume that I want this 5 to be the maximum. What can this 5 match? Okay, let me zoom a little bit. I'm not sure how to zoom it. Okay, great. Okay, so let's assume that I want to make this 5 act the maximum. So 5 acts the maximum. So which element can I pick? So I can I pick 6? No. If I want to make 5 at the maximum, and in that particular sequence, 5 and 6 cannot coexist. So what I mean by that is that if there's like a subsequence that I want 5 to be the maximum, so if there's a 6 in here, so 5 cannot be maximum because 6 is larger than 5, so it will take over 5x as the maximum, so it won't work. Actually, any number in here will not work. Because if you pick any number on the right hand side here, it will make 5 not being the maximum, because the array is already sorted. Anything on the right hand side will have a larger value than 5. So that's the reason why you should always look at the left hand side only if you want to mark 5 as the maximum. So that's why if you want to mark 5 as the maximum, you can only pick one of these elements from here on the left hand side, namely. So one example will be 5, 1, and another example will be 5, 2, another example will be 5, 3, or another example will be 5, 4. That contains all the subsequence of size equals to 2, but sometimes you want to consider, more than just size equals to 2. That's why we have to kind of loop the k as well, because you need to. So basically, you can just look at here. There are like 4 choices you can pick. If we want to make subsequence size as, for example, like 3, and there are like 4 choices that we can pick. So it can be 1, 2, 3, or it can be 1, 2, 4, or it can be 2, 3, 4, and so on and so forth. Basically, we want to, there are like 4, because there are like 4 elements here, 4 in total. 4 choose 3, because we want to make the subsequence size as basically we want to make the subsequence size as 4. So we need to choose 3 elements here, because we also need to include 5. So we choose we want to make the subsequence, the total number of subsequence size as 4, and then we also include 5. So they already take 1 place, and then we need to take another 3 places from here. So basically you just need to pick for choose 3 here. Okay, so that's for the left hand side, and for the so yeah, for the left hand side that we can do that, and we only consider the subsequence size as 4, but we haven't considered everything, because the subsequence size can be 3. So if we want to make the subsequence size as 3, then it is not 4 choose 3 anymore, is 4 choose 2, because you want to make a subsequence size of 3, and you need to choose 2 elements from the left hand side. And then whatever you pick here, it will not change the fact that 5 will be the maximum because it is already sorted. And so you can just for choose 2 here. So yeah, that's basically the idea. Okay, let's see. Is there anything left to exploring? So this is if you think about it, this is how you consider that's how you can pick how many ways you can pick 5 as the maximum. So to generalize this, like to give it a formula. So if we want to mark certain nums I as the maximum, then what we have to do is just choose, and we just need to do an n choose k where n is I, because, well, if you are doing 0 index, and you know this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, I mean the index. So if you're considering the index 4, so there are exactly 4 elements here that I can pick from. If I pick them, this particular element will still be their maximum. So basically, if you want to make nums I as the maximum, you can do like n equals I, and then k equals to k equals to and choose k equals to j. Basically, j is something that you have to loop. It's not necessarily k, because as I mentioned, there could be multiple size as long as it doesn't exceed k, and it will be good enough. So for j, in like so it can be like you can pick just one element, or you can pick you cannot pick k element. The reason why is that the way that I've written it right now, if you pick k element and then you also consider 5, then that will be k plus 1 in total. But we want k in total, so we can only pick k minus 1. Of course, this k minus 1 should not exist I as well. So whatever is smaller, so you can at most pick I or k minus 1, whichever is smaller. Okay, that's how we calculate the maximum. And the way to calculate the minimum is actually easier. So in general, if we want, so let's say nums I as the minimum, so let's take a look at this example again. So if I want to make 5 as the minimum, we can choose any element here as well, right? So there are like 4 elements here again. So how do we get 4? So this is a basic formula. So here, the 1, 2, 4, there are like 9 elements here. So the element on the left is basically 4. We know because we counted 1, 2, 3, 4, which happens to be like n is 9. 9 minus the current index is 4. So it's n minus I, which is 4, which will be 5, and minus 1. So that's how I get this. So basically this one, n minus I minus 1, will always be the number of elements that we can pick on the right. That no matter what I pick here, for example, I can pick 12 and pick 15, I can pick 10, whatever I pick here, it won't change the fact that this 5 will still be the minimum, because again, it is sorted, so everything on the right hand side will be smaller than it, so it doesn't matter which element that you pick. Okay, so here it's actually very similar, so you just choose n equals n equals to n minus I minus 1, and then k equals j again. J is something that we need to make, we need to loop, or j equals to at least, we need to at least loop 1. And then we need to okay, so we need to pick, we at most can pick k minus 1 again, and also for the total number of, so this n minus I minus 1 is the total number of elements on the right hand side. So we're gonna pick that, whichever is smaller. So that's basically the the flow of the algorithm. Okay, I think that is not that complicated if you can figure this out, and the rest is just how to figure out the modular math in order to calculate this and choose k in under the modulo 10 to the power of 9 plus 7. So in total, this the time complexity will be like n times 70, n times k basically, because k is so small, it's only 70, so it will work. And plus n log n basically, because we have to sort it at the beginning. Okay, so yeah, just I'm trying to remove some of the complexity here to copy and paste the portion where you calculate the n choose k, because it is pretty much reusable for a lot of places. In here, I only care about n choose k, this API, basically. So this is the answer. Answer equals 0, and at the end, maybe is it here? And I'll just return answer. So for I equals 0, I less than n, I plus plus. And for each number, I'm trying to figure out if it's what happens if I go into take it at the maximum or minimum. And for j equals to 1, j less than k minus 1 basically, because as I mentioned, we cannot pick k element. We can at most pick k minus 1 element. So actually it's here. So one boundary case is we don't pick anything. So if we don't pick anything, we just pick. So as you can see here, we just pick this nums I as the minimum and as the maximum at the same time. So this will be just add answer mo nums, just basically it is answer plus equals to, it's just answer plus equals to nums I times 2, because once is the minimum and once is the maximum. And then there's like a boring case. The more interesting case is you actually pick something from the thing that we can pick. Oh, I have to sort it as well. Sort nums begin, nums end. So nums So this one is how should I put it? We need to pick J elements. Pick J elements to form subsequences. To form a subsequence. Okay. So if we want to pick J elements, so if you want to form if you want a subsequence where num psi is the maximum, so you can choose the elements on the left hand side. So basically I'm talking about here. So answer equals to add answer. Let's choose. Well, there are like I elements that you can choose from, and you need to pick J of them. So because each one of them will be included at one of the answer, and all of them has to be multiplied by num psi. Okay. And that is the case to make num psi as the maximum, yeah, because you're choosing things from the left hand side. So whatever you pick, you will not change the fact that num psi is the maximum. Okay, so this, and then I'm gonna do the similar thing, but this time I want to consider num psi as the minimum. So like there are like n minus I minus 1. Basically, it's all the elements on the right hand side that I can pick because it is already sorted. So whatever elements on the right hand side, I don't care. If I can pick them, and I'm gonna pick J of them. So so it won't change the fact that num psi will still be the minimum. So because it is a minimum, it will be one of the answers. Okay, so there's one small problem, is that what if J is larger than what if J is larger than I? So we just need a little bit check if J is because you need to pick J elements from I, so J has to be strictly smaller than I, then otherwise it won't make sense. For example, free choose 5 doesn't make any sense. Okay, and then this is gonna do the similar thing in here. N minus I minus 1. So this is to consider nums I. Okay, maybe I'm thinking how to organize it a little bit better here. Consider nums I as the minimum, right? Is it the minimum? Sorry, it's not. It's the maximum. Yeah, I'm already a little bit confusing. Okay, sorry. So it is the maximum because you're choosing stuff on the left hand side. So no matter what you pick, it won't change the fact that num psi is the maximum. Similar thing as the minimum. Yeah, same thing here. You're choosing stuff from the right hand side. So no matter what you pick, you will not change the fact that the num psi will be the minimum because they are all larger than num psi after sorting. Okay, I feel like a broken record for saying the same thing over and over again. Anyway, it should work. Let me see if there's, okay, I haven't declared n as nums. So let's try to think. Yeah, it should be working. Let's try to run it. Okay, it's a bit, and choose and permute k. Okay, that's not how I call permute. Okay, sorry, there's something wrong with my library. What happened now? So, 3. Oh, okay, I have to initialize this factorial. Yeah. Let me think. So they need to, because if you know about math, when you calculate and choose k, you somehow need to do the factorial. So I have to initialize the factorial here as well in order to use it. So faxt equals to factor and n, and an inverse faxt equals to int n. So faxt 0, factorial 0 is 1, and then equals 0, look at less than n, and plus 1 actually. So fact I will be faxt I minus 1 times I and then faxt invert faxt is like invert faxt is just 1 faxt I, basically. It's like this. Invert faxt I will be this one. This is also it, because we have to define the factorials, and the way that you define factorial under modular is a little bit of math again. So we have to do inverse here. Fax n. So you're going to reinitialize the inverse of factorial n is the inverse of factorials n. And then we can calculate the rest. I greater equals to 0, I minus. So inverse faxt I will be inverse faxt I plus 1, because the way that we calculate it, I plus 1 should already be an answer that is ready. So inverse faxt I plus 1. Well, so it's like this. 1 over n, let's say n factorial, this number times n will become 1 over n minus 1 factorial, because it cancels out. So if you mod it, then it will be the inverse factorial of the current 9. Okay, now we have populated inverse factorials and also the factorials. we should be able to use this choose function correctly. Let me run it. Okay, so some wrong answer. 24. I wonder what's going on. Answer equals to nums I. Can choose at most k minus 1. Such. Okay, sorry. You have to calculate from n minus 1. Let's try it again. Okay. Let's try to submit it. Okay, accepted. Any other fault? Yeah, this problem, even though it's medium, I think it's like a really hard problem. So yeah, it took me quite some time to solve it. So yeah, don't feel so discouraged if you cannot solve it on your own. And thank you so much for watching, and I will see you next time. See ya.